You are welcome to our today's edition of online lesson. My name is Mrs. Okinini. Our topic today is inverse or indirect proportion. Inverse or indirect proportion is the type of proportion in which as one quantity increases, another decreases, or as one quantity decreases, another increases. Inverse or indirect proportion. When you say indirect, that means they are not moving in the same direction. They are moving in opposite direction. They are moving inversely. They are not coming together. So it means that as one quantity is moving the other way, the other one is moving the other way. So as one quantity is increasing, the second one is decreasing. And as the other one is decreasing, the second one is increasing. So they are indirect. They are indirect. So example of indirect proportion. Example 1. If a student travels a certain distance, then the greater the speed, the less time it will take. So here we are considering the speed and time taking. Speed and time taking, they are the two relationships, the two variables that we are comparing. Speed and time taking. So we said that if the speed increases, the time taking to cover a certain distance will reduce. So the table, from this table 1, the table below gives the corresponding speed and time for a journey of 100 kilometers. The distance is 100 kilometers. Then what the two variables we should consider is the speed and the time. So if the student is moving at a speed of 10 kilometers per hour, 10 kilometers per hour is moving at 10 kilometers per hour, then it's going to take him 10 hours to cover a journey of 100 kilometers. And if he's moving at a speed of 20 kilometers per hour, then it will take him 5 hours. If he's moving at a speed of 25 kilometers per hour, then it will take him 4 hours. And if he's moving at a speed of 50 kilometers per hour, then it will take him 2 hours. So the higher the speed, the lower the time taken to cover the distance. So another example is when you are coming to school in the morning, assuming you are living in Barangolo, if you are walking sluggishly, you will come when we have finished assembly because it will take you higher time. It will take you more time before you reach the school. But assuming you take a bike, you will come before the assembly because you've increased your speed. Or if you are even running, it's still better than when you are walking sluggishly. So the higher your speed, the shorter the time that it will take you to get to where you are going. So if you increase your speed, then you will reduce that automatically have reduced the time that it will take you to cover a certain distance. So looking at the table, we can see that when the speed doubles from 25 kilometers per hour to 50 kilometers per hour, the time is halved. The time is slashed into 2, from 4 hours to 2 hours. So it's 50 kilometers per hour over 25 kilometers per hour will give us 2 all over 1. Then 2 hours over 4 hours is 1 all over 2. So the time is reduced from 4 hours to 2 hours, and the speed is increased from 25 kilometers per hour to 50 kilometers per hour. So we say that this relationship, the ratio of any to speed, 50 and 25, is equal to the reciprocal of the ratio of the corresponding time. Reciprocal 2 over 1 is reciprocal of 1 over 2. So we say that the time taken is inversely proportional to the speed, or that the time varies inversely proportional to the speed, or we say time varies inversely with the speed. The time varies inversely with the speed. So we say something about reciprocal. Reciprocal means inverse of a number. So when we say reciprocal of 2, it means 1 all over 2. Reciprocal of 3 is 1 all over 3. Reciprocal of 1 all over 2 is 2 all over 1. So we say that the ratio of any to speed is equal to the reciprocal of the ratio of the corresponding time. When we consider the ratio of 20 and 10, which is 20 all over 10, that is 2 over 1. And we consider the time 5 over 10, that is 1 all over 2. So we see that they are reciprocal. So, example 2. A cyclist travels 40 kilometers between 2 villages. Draw a table showing the speed if the journey is 1 hour, 2 hours, and 4 hours. B. Is the speed directly or inversely proportional to the time taken? C. If the cyclist travels at 18 kilometers per hour, find how long the journey takes. Solution. Table 2. Time in hours, speed in kilometers per hour. So the variables we are comparing is time and speed. So if the cyclist is moving at a speed of 40 kilometers per hour, then he will cover his distance within 1 hour. But if he's moving at a slower speed of 20 kilometers per hour, then the time taken will increase to 2 hours. Then if he still reduces his speed to 10 kilometers per hour, then the time taken will increase to 4 hours. So that is solution to question A. So B, from the table we can see that if we double the time, the speed is halved. Thus, the speed is inversely proportional to the time. When we double our time, then the speed is halved. When we double our time, like when we move double our time, when we from 20 kilometers per hour, we doubled it to 40 kilometers per hour, our time is halved from 2 to 1. And when we double it from 10 kilometers per hour to 20 kilometers per hour, the time is halved from 4 to 2 hours. That is it. They are inversely related. The higher the speed, the shorter the time taken. So question C. The question C states that if the cyclist travels at 18 kilometers per hour, find how long the journey takes. So using time is distance all over speed. Time is distance over speed. Our distance is 40 kilometers. Then the speed is 80 kilometers per hour. So it's 40 all over 18, which is 2 whole number, 2 all over 9 hours. And it's approximately to 2 hours, 22 minutes. It will take him approximately 2 hours, 22 minutes to cover a journey of 40 kilometers if he's moving at a speed of 18 kilometers per hour. So this is your assignment. Do your assignment and submit as usual. Thank you very much. Once again, I am Mrs. Okene. Thank you.